Hansikayana Kanad.
Actually, we are not started with the session. We'll start it soon. Hi, everyone. Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to the day two of the Networking International Conference on Emerging Trends in Expert Systems, Applications, and Safety and Security, Asia Chapter 2025, and as we fondly call it, the TEAS Asia 2025. I am Hansika Dabas, and it's an absolute pleasure to moderate today's online session. This international conference is jointly organized by the Banking Academy of Vietnam, Hanoi, Vietnam, and Apex University, Jaipur, India, supported by Shree KKarni University College, Jaipur, and managed by Consultancy Services, India. This year, we received an overwhelming response with over 400 paper submissions from across the globe. After filtering out AI-generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by the Springer Nature. Yesterday, on the 29th of October, the day first of the conference, we had an incredible series of keystones. Paper presentations, award ceremony, and a discussion that truly embodied the spirit of innovation, inclusivity, which was offline in Vietnam. Now, as we step into the day two, we carry forward the same enthusiasm, ready to dive deeper into the thought-provoking session and interactive presentations that will shape the future of intelligence systems and digital security. With that, I am pleased to introduce our session chair for this segment. First, I would like to introduce Kanad, the Director of Amity Cognitive Computing and Brain Informatics Center from Amity University, Jaipur, and Lavika Goel, ma'am, who is an Assistant Professor of Department of Computer Science, MNIT, Jaipur.
Thank you, madam, for the introduction, and I think we can begin the session.
Yes, ma'am. Before proceeding, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First of all, each presenter will have a 7 to 8 minute time period, so please stay within the time limit. Second, briefly cover your research context, objectives, methodology, key findings, and conclusion. After that, a short Q&A may follow up your talk of 1 or 2 minutes, so keep your responses brief and focused. Keep your mic muted when you are not speaking. And the last but not least, for the full session to support the fellow presenters. With the kind permission of our session chairs, we shall now proceed with the paper presentation.
Yes, madam. How many papers are there, Hansika, madam?
There are actually 4 papers, ma'am.
4 papers in this 1.5 hours?
Yes, ma'am.
Okay, fine. Okay, you can go ahead, please.
Yeah, thank you, ma'am.
Okay.
So, with the kind permission of our session chairs, we shall now proceed with the paper presentation. I would like to invite our first presenter for the day, presenting the paper titled Leveraging. Okay. Presenting the paper titled Leveraging Multilingual Vernacular Speech Repository for Acoustic Profiling of Mental Health Conditions, a literature review under paper ID 342. I would like to request the author Shalini S. to please come on the virtual stage and begin their presentation. Over to you, ma'am.
Yeah, thanks for the introduction, Hansika. So I'm here to present my paper. Let me just share my screen and give a brief intro, and then I'll just start presenting.
Sure.
Hope my screen is visible to you all. Is my screen visible?
Yes, it's visible.
Yeah, thank you. So I'm Shalini, and I'm doing my PhD under Bardiyar University, India. So I'm here to present a paper on leveraging multilingual vernacular speech repository for requesting profiling health for the mental health condition. This would be a literature review kind of paper, and on the conclusion, our research gap analysis and problem finding will be stated. So let me just proceed for the abstract. So I've compared multiple papers under this review, which is basically based on all the mental health disorders and how speech induces or helps in that kind of acoustic profiling. So we have several acoustic disorders or mental disorders like depression and anxiety. So why we are inducing speech into this problem statement is that speech is non-intrusive and it is very simpler, and we can early detect all the health conditions based on the speech. So we have certain biomarkers or acoustic biomarkers, and we have tried to combine mobile sensing technologies and machine learning technologies for these kind of sorts. So most of the papers which we have compared are all clinical based and basically based on English. So we have identified certain gaps in that, and I would like to propose a system through this review analysis. Let me just dive into the introduction. So we have certain acoustic biomarkers like pitch, variation, shittering, whispering, lower intensity, or pause rates, or speech rates. These are all certain attributes of speech which could contribute to the acoustic profiling. So for the prediction of mental health condition, we have chosen speech because it is very simple, and it can be captured very simple, and early detection will also help. With the attributes which I've mentioned earlier, we could sense all these disorders in early, and we can just report that to the biomedical team. Here are certain papers which we have compared. First of all, we have compared the paper from Low et al., and they have used voice data and natural language processing for the mental disorder or mental profiling. The thing which is lagging is that they have only clinical or laboratory environment based data, and mostly they are English centric in terms of Low et al. And we have also compared one way paper from Dioscar, and they have collected certain non-clinical data, but then all those things lack certain metadata. And there is a lack of ecological and linguistic diversities. And going back to other papers by Lemenshin, they are also laboratory centric data, and they have also collected certain real value audio, but then the behavioral aspect and the emotional aspect of their metadata was lacking. And I've also reviewed this Ratnayaka paper, and here the smartphone interaction was there, but then they did not integrate that with the speech data. And we also have Quine, and they have used explainable AI technologies for their speech or acoustic profiling for mental disorders. But then clinical trust and other essential factors were lagging over there. So automatic diagnosis were there, but that is not that trustworthy to depend on the machine learning part. And I've also compared certain papers by Beham, and that is also limited to English speaking users. And they have the accuracy was also like they have certain accents or noise background limitations over there. So proceeding to Zwan, they have data governance and privacy policies highlighted, but then the wide spectrum of technical aspects weren't used over there. So there were certain shortfalls on consideration of acoustic data, particularly certain vital information on relational variations or geolocation metadata. And there are two papers which were also considered, which is Lee with they have linguistic and ethnicity disparities in their data set, and their accuracy level was a little bit low when compared to the other papers. And we also have Turi and et al. Paper, and that is where the deployment with the mobile application was lagging. Like they have the clinical relevance and they have the vernacular relevance as well, but then the deployment of mobile application was lagging. So I have also compared all those papers in a table. I'll just share that tab. Yeah. So here is a comparison table on what has been lagging and what was the key finding. And also, I've also given whether there are certain attributes like control data or accuracy, real world relevance, metadata, behavioral data, speech audio coverage, inclusion of vernacular languages, scaling, data privacy, and acoustic prosodic future scope. So all these attributes were compared, and all those papers were analyzed if they have fully covered it or partially covered it or not covered it. So NA indicates not covered fully or not, and fully access is like fully, FA indicates fully covered and partially covered is PA. So this is fully addressed, partially addressed, and not addressed. So with respect to the, sorry, one second. Sorry, that was a network error. I'm just getting back to it. Just 1 minute of time. Sorry for the interruption.
It's okay.
Yes. Sorry for the interruption again. So this is the conclusion from all the comparative studies. Like there are first thing is vernacular part was missing. Mostly it is all English based. Second thing is all the things were mostly based on clinical conducting of speech recordings, like clinical observation of speech recordings, or it is all based on laboratory. And even if that too is met, metadata of their particular user was not there, and accuracy also plays a major role in these attributes. So with all this shortfall, we have concluded to leverage the multilingual vernacular speech repository, which is we will have a mobile device enabled Android application or iOS application and application where the metadata of the user will be collected: name, their geographical location, which if they are willing to give, and their description of the description of the particular speech, and the speech will be recorded, and there will be a live playback action over there, and they can delete the speech anytime, and then they can re-record and then present the speech. So all these collected speech will be in the vernacular language. They can choose any language they want, and it will be captured in the mobile devices. This will ensure that the speech can be collected in a simpler form and it is accessible for the all point of view. And this collected speech can be exported by the person, and it can be noise detected, and it will be further proceeded for the attribute identification using missing language techniques, and that will factor into an acoustic profiling of the data, which is our gap analysis. So this is the references I have taken, and all the authors and their research works which we have compared has been presented over here in the references. So this is all regarding this leveraging multilingual speech for our mental health disorders. So we have covered the part of mobile application development, and we are ready to start with the analysis part using machine learning for the attributes of speech to make it into an acoustic profiling. And this will serve for the mental health disorder people. Yeah, thank you. Any queries or we can proceed?
Thank you so much, Shalini ma'am, for such an insightful and well articulated presentation. Now we are open for questions. There are, if any.
I have one question. Uh, so how effectively this can and this acoustic features extracted from multilingual and vernacular speech repository distinguish between individuals with depression, anxiety, and healthy control across diverse linguistic and cultural contexts. If you take that, how effectively these acoustic features could influence that, distinguish that.
Yes, sir. So basically, we have went for the vernacular languages because it should be accessible for each and everyone in spite of their literacy rates. So it is not only based on English. We are attributing the metrics like shuttering, shimmering, or the pause metrics. In spite of languages, we focus on the attributes of the acoustic elements. So this will help us overcome this vernacular aspect. So we are not focusing on a particular language. The language is a barrier for this for the certain people to come up and speak. But breaking that barrier, we are considering only the attributes of speech, which will be like, as I've already told you, like shimmering, jittering, or pause metrics, or other emotional conditions which overwhelm in the speech, no speech rate kind of things. So only attributes are taken for the consideration.
Okay.
I think it is fine from my side, Hansika.
Thank you so much. Thank you so much. Thank you. Yeah.
Yeah.
So if there are no more questions, we can proceed.
Yes.
Sure, ma'am. So our next paper presenter is under paper ID 344, paper titled Performance Comparison of Face Detection Algorithms Using Celeb A Dataset by author Nihal Kumar Patel. So over to you.
Hello, good morning. Uh, Let me share my screen.
Sure, sir.
Is it visible?
Yes, sir.
Okay. Good morning, everyone. I am Professor Nehal Patel from Vinama South Gujarat University, and today we are presenting a research paper based on performance comparison of face detection algorithm using the Celebi dataset, co-authored by Dr. Bharat Patel. So basically, the outline of this presentation is will be introduction, review from the literature, algorithm reviews, dataset and implementations, interpretation of data analysis, conclusion, and future work. So face detection is the core task, which is based on detecting faces on not only from the images, also from the real videos as well. So traditional methods like Haar cascading and DLib-Hog was the first algorithms, and CNN-based model algorithms are like MT-CNN, SSD, and Retina phase. These five algorithms are used to make the performance analysis from this Celebi data set. Objective of this study is that comparing these five popular algorithms based on the dataset accuracy provided, precision recall, and robustness and flexibility based on their confusion matrix. The review from the literature. First, Vela Jones, which is also called as Haar cascading, it was the first algorithm introduced in 2001. It is algorithm based on detecting faces based on the features of the faces. So DLib-Hog is also the same as the traditional algorithms, which is introduced in 2009. MTCN and SSD and Retina, these three are the deep learning models, which are detecting the based on the data of the images or the videos. So deep learning model outperform all these traditional, which is VLOG and DLib-Hog, and based on their accuracy and the performance. Algorithm overview. The Haar cascade, it is the classical type of algorithm, which is also fast and lightweighted and used in most of the time on small scale of application. DLib-Hog, feature-based algorithms. MTCN and SSD and Retina phase, they are deep model network algorithms. And SSD is the single state, which is used for mobile application as well. So these algorithms have their own strength and their own limitation. While you can see that Haar cascade is a very lightweighted, but it gives a very poor performance on the face detection. While the Retina phase gives the best accuracy, but it is slightly heavier than other traditional algorithms. Dataset and implementation. We use in this study Celebi dataset, which contain more than 2 lakh images of celebrities. These celebrity images are their frontal faces, one-third faces, slide faces, faces with ocular tattoos or makeups, and we have to perform these five algorithm perform on all these images. But 2 lakh images more than we can cover. So what we did, we took only 10% from these images, and the tools that we use is OpenCV, DLib-Hog, TensorFlow, and PyTorch. We use 0.5% IOU threshold to compare it with the ground truth. So this Celebi data set also have the 40 plus annotation of the frontal landmarks. So we compare with both that, and we created a confusion matrix from that. And from that confusion matrix, we also created we also get the precision recall, F1 score, accuracy, and FPR. These all pre-trained models are, we didn't touch and we didn't made any modification in it, and we just perform and compare with each other by just fine-tuning it with the Celebi dataset images. Okay, that's the interpretation of data analysis, that it content that Retina phase achieved the highest score in that in all the thing. Precision recall F1, in everything it get 99%, and with the minimum FPR, fault precision rate. So Retina phase is a base field in all the metrics, while the SSD got high recall but poor precision. So Haar cascade algorithm complete their work in around 8 or 9 hours, while the Retina phase took more than 2 days to complete to process the 20,000 images to get this kind of accuracy. Okay. The conclusion on based on that, the deep learning model outperformed traditional one's celebrate dataset. Retina has achieved the highest precision in recall. MTCNN provides the balanced performance. DLibHawk Harkas suitable for lightweight and real-time use, while SSC need refinement, reduce a positive, false positive. Result validates Retina Face MTCN most efficient model for structured facial. So Retina Face clearly wins the on all the thing, while the SSD was the last one. In future, we want to combine this detection with the recognition model. That means on any image, we detect the face, but the face recognition is the other part. So which face it had content, that image content is also next part in the recognition as well. We also want to extend this study on wider face data set. This is also a complex data set. We want to test their performance on the wider face data set as well of these 5 algorithms as well. We want to develop a hybrid model to merge any algorithm based on that, optimize for real-time edge devices for low light oculation handling. Many algorithm doesn't perform well in the oculation or low light images or the real-time images. So we want to perform that optimization as well. So that will be our future work. And that's my presentation. Any query for that?
Thank you so much, sir, for such a thoughtful session. If there are any questions, please go on.
Just one, query is under varying, lighting or occlusion conditions. How it would work. So the conventional ones and the so is there any? Have you checked that one?
Yes, sir. The celebrate dataset contain many faces where their faces may have oculation as well and shadow as well. In few images, there are tattoos also marked on the celebrity faces. So traditional algorithm couldn't perform that much well compared to the CNN models. So in our study that we found out that CNN models can outperform the traditional methods.
Okay.
Anything else, sir?
Yes.
From my side, it's okay. So if anybody else,
Thank you. Thank you, sir. Thank you, ma'am.
So if there are no more questions, we will proceed further for the next paper. Next paper titled A Grey Box Testing Framework for Enhancing Mobile Application Reliability under paper ID 349. I would like to request to call Piyush Parekh on the virtual stage. Over to you, sir.
Am I audible and visible to you?
Yes, sir.
And my presentation is visible to you?
Yes, sir.
Okay. Thank you so much. My presentation, my paper ID is 349. The Grey Box Testing Framework for Enhancing Mobile Application Reliability. We are the two authors over here. I'm myself Piyush Parekh and my guide, Dr. Mahipal Singh Devra, sir. This is my research work. So here in this Dept, we have targeted for developing a Grey Box testing framework for the mobile application testing. The approach for developing this framework is combining the static analysis and dynamic analysis. The static analysis and dynamic analysis of the two different testing frameworks of the black box and white box with the knowledge-driven feedback added to this GBT framework. The outcome of this framework is around improved 91.3%. The execution time of the black box and the white box is being compared with the gray box and black box. The relevance is the optimized of the CI/CD pipelines, and it can be added with the QA automation option. The motivation for doing the work on this topic is that the mobile apps are dominating to the major required streams of the life. There are still the challenges for the mobile applications, as there are the variation in the devices and the operating system fragmentation. We have the majority of the two operating systems, the iOS and the Android, in the market. Android has captured around 80% of the market, and the rest has been by the iOS and the rest of the operating system. The frequent versioning change of the updates is still a challenge for the mobile application testing. There are the different variation in the hardware and the sensors, that is the dependency on the data from those sources. The dynamic UI rendering, which is been taking the screen and size in the screen behavior. Still, the traditional testing strategies are very shallow in nature, which are opting for the black box, and which are going in depth, they are opting for the white box testing. Both of them are having their own flaws. So we have gone for the existing approaches and their limitations. The black box is easy for the automation, but it has the flaw that the code behavior cannot be tested. For the white box, it is, yes, it is deep structural, but it needs the source code access, and the developers and the companies do not provide the source code access to the testing teams. Yes, if we go for the model-based testing, it covers the functional flaws, but it lacks for the runtime adaptability. We have worked on the hybrid gray box, where we have the partial code in the runtime environment, which is giving certain benefits for the existing one, but it has the limitation that there is a need for the semantic framework. So we have come up with a new framework, which is unified, data-driven, and which combines the structure and behavior functionality. So here I propose the GBTF architecture, which is a gray box testing framework that integrates the analysis, monitoring, and feedback. The core modules includes the statistical analyzer. This extracts the classes and the dependency from the application. So we go for the first step over here. The mobile application has been statically analyzed, that's with the for the UI graphics, and from the APK for the class dependency. Then we go for the dynamic monitoring. That dynamic monitoring tracks the runtime events and system users. Now both of these, we have the dependencies and the graph with the track of the runtime environment. Now we generate the test generator, which is generating the test using the ML heuristics. This now generates the test with the events, and now they are reversed. They are checking for the coverage evaluator, which is measuring that how much that is needs for the improvement. This is the workflow of the algorithm. Here we first execute the static analysis. We need the hooks to get and capture the UIs. Then we generate certain tests for checking the behavior of the application. The activity graph is being generated over here. Then we execute and monitor the runtime. This coverage is having the updates. Now these updates are being checked with the code behind. If there is something threshold, we again go for the test case generation. If this is satisfied, then the whole application is being tested. We will take one example of the case study. We have checked the framework with the FinSecure banking application, which has the multi-factor authentication. They have transaction of the bill payment module, the biometric login, and the third-party API integration. This model extraction, the reverse engineered the APK from the manifest file. It dynamically traces the UI elements and put out their events and the graphs. They are then traced with the test cases, and the transaction is then executed and checked. We have used the environment for checking the Android 13 emulator. The tools are Android Studio, APM. Datasets are around 120 functional scenarios. We have checked with 450 users. The metrics are branch coverage. This is a small result that we have got from the module-wise checking of this application. The logins were tested with the 35, fund transfer with the 40. Defects we have found for the login was 5, and it has around captured 93.5 coverage area. From here, we can see that the application been checked with a coverage of around more than 89% across all the modules. We have compared this with different other testing mechanisms. If we go for the manual testing mechanism, it has a line coverage of around 62, branch coverage of 55 only. And the execution time needed is 180. The fault detection is 61%. The black box, which is going for 75% of the line coverage, it is checking, because in the black box we have only the UI. For the branch coverage for 68 and execution time 140, and the fault detection is only 66%. But when we go for the GBTF, it is having the line coverage of 92, branch coverage of 88, and execution time of 102, and fault detection is 88%. So we can say that the GBTF achieved 17% high of the branch coverage than the black box, 40% more than faster execution, 22% better defect detection. We have also worked on the different mechanisms of the code coverage. We have compared the GBTF with the Robotium, Expression, and Monkey. The Robotium supports 24% covered, and Expression with 24%, Monkey with a 24%, but the GBTF is still having the lead with 28%. The fault detection comparison of the GBTF is more than the other, the Robotium, Espresso, and the same Monkey.
So you have reached the time limit. Please wrap it up soon.
Yes, it is done. The key insights are the testing the bridge between the structure and the behavior. The GBF ensures the automation, scalability, and coverage behavior. We have worked on the GBTF with the mobile app with the unified static and dynamic feedback loops. The future, we will be working with the AI-driven test prioritization and energy profiling. And we will be adding this to the CI/CD pipelines. These are few of the references. Thank you. If you have any questions, I'm open to it.
Thank you so much, Pure Sir, for such a well-structured presentation. So if there are any questions, please go on.
So one question, just one query, can it be used to, to have you check or enhancing the fault tolerance of mobile applications, fault, if you have something you have done already on that, so the fault tolerance of mobile applications, can we use that?
Yes, sir. We have done with the fault tolerance also. I had given the result also.
Okay.
You want me to show again?
If the time is there, just for 30 seconds, if you can show.
Sure. I'll be showing you. Don't.
I think after this only one presentation is there, Hanshika. One presentation is there.
No, sir. 2 more are left.
2 more. Okay, because I have some urgent meetings. By 2, I'll be leaving 1:55 or so. So I think Professor Goel would be, here.
Sure.
Be,
here we have the fault detection.
Yes. Fault tolerance and mobile for mobile.
They are all for the mobile application.
Yes, for all of us. Fine.
Thank you so much.
Okay.
Thank you so much, everyone. Now we'll proceed for the next paper. So, paper titled Comparative Performance Analysis of Traditional and Transformer-Based Approaches for Binary Sentiment Classification under paper ID 3354. I would like to request Akansha Srivastav to please come on stage.
Am I audible, ma'am?
Yes, ma'am.
Good morning to one and all. Let me share my screen first. Is my screen visible to all?
Yes, ma'am.
Okay. So good afternoon, everyone. Today I'm going to present on the topic comparative performance analysis of traditional and transformer based approaches for binary sentiment classification. Myself, Akansha Srivastav, and as a co-author is Pushkal Desai sir. I am a research scholar from Computer Science Department, VNSU, India. Okay. I'm going to start. These are my outline that I'm going to cover in my presentation. That is introduction, the motivation, research objectives, proposed methodology, dataset and model architectures, experimental result, conclusion and impact, and what will be the future work. Okay, so I'm going to analyze, do the analysis on sentiment. So sentiment analysis, as we all know, is a crucial in understanding public opinion across platform like reviews, news, and social media, as we are living in a digital world. I'm going to compare traditional model and transformer-based model. In traditional model, we are going to cover logistic regression, Navy-based, SVM. These are covered on the basis of literature review that I have already done. And transformer-based model, we have taken BERT. Okay, the research objective of my paper is to perform a comparative analysis between traditional machine learning models and transformer-based architectures for binary sentiment classification to evaluate model performance using standard metrics. Accuracy, precision, recall, and F1 score has been covered. And the data set that has been taken is Kaggle. It covers the IMDb movie rating to identify the most effective and context-aware model for sentiment prediction task and to analyze trade-off in computational complexity, training efficiency, and overall model interpretability. This is my proposed methodology that we are going to data collection has been done. That is Kaggle IMDb movie review data set. Then we have processed the data. First, we have done text cleaning, tokenization, then stop word removal, lemmatization for normalization. After that, features extraction have been done in traditional model. I had done using TF, IDF representation, and for transformer models, contextual BERT embedding has been converted. That is, it has been converted into 768 dimension vectors. Okay, so we have also combined these two traditional and transformer based model and given hybrid approach, that is a fusion of traditional and transformer based models. In that, BERT embeddings have been combined with traditional TF, IDF features to enhance contextual and statistical understanding. The model training have been done on LR and NB, SVM, and custom fine-tuned hybrid model. And for evolution matrices, we have taken accuracy, precision, recall, F1 score for performance comparison. The data set is again Kaggle IMDb data set, in which it is a balanced framework data set that covers 80,000 positive and 79,000 negatives review. We had split that data in 80-20 ratio, 80% for training and 20% for testing. Architecture review of my paper is BERT transformer encoder used to generate 768 dimension contextual embedding for each text input. This I will be showing by giving this example. That it is this is our data input. In input, we had combined the fusion, that is our traditional approach, and this is our transformer based approach. In traditional approach, TF, IDF features has been taken, and in transformer based approach, 768 dimension and contextual embedding has been done. The fusion of both has been taken. Why the fusion has been taken? Because in traditional model, context is not been taken by the model. For example, the movie was great, but it only take the words or frequency of the words like the movie was great. It doesn't cover the context. While in transformer based model, it covered the context. Like it take the relation between movie and great, so it will take it as a positive. While traditional cannot do this. If you are taking traditional model, then frequency is taken, and if you're taking transformer model, that context been taken. But the problem with transformer based model is that it has to be fine tuned on multiple epochs, and it takes multiple days to train. So we had combined the features of both two, and we had developed one hybrid fusion layer that then this will only do the embedding process that takes only 2 to 3 hours, and then the input will be given to our traditional that is frequency based approach, and it will give you the sentiment classification that is in positive and negative. These are the results that we have taken using traditional LR and Navy based SVM This is from transformer based model, that is BERT. As we can see, the accuracy is too low, as this has to be fine tuned. Otherwise, this does not give a proper output. So to overcome this challenge, we have converted this to BERT custom. That is, as we have seen, embedding combination of embedding with features extraction. So we can see that our custom model gave us 84% accuracy comparatively to all these models. The result confirmed that fine-tuning transformer on specific data sets substantially improved performance. Our custom BERT achieved F1 score above 0.85, proving its superiority in binary sentiment classification. Standard BERT performed poorly due to insufficient domain fine-tuning. As I said, we have to fine-tune, and that take multiple days to fine-tune it. Their ability to capture bidirectional context improves sentiment prediction accuracy. The future work that is going to be done on this paper is extend that we can compare multiple class sentiment data set. This can be evaluated on real-time performance using multi-source data like on news, live news, Reddit, YouTube comments, and optimized transformer models for faster inference using quantization and pruning. Thank you. Any queries?
Thank you so much, Kanchi ma'am, for such a great session. Any questions, please?
Thank you, ma'am.
Okay, so if there are no further questions,
Thank you.
the audience or session chair, we shall now proceed to the next paper. Thank you so much, ma'am.
Thank you. Thank you.
Now, I would like to call paper titled The Human Firewall, Enhancing Information Security Awareness and Reducing Cybersecurity Risk in the People's Credit Fund System under paper ID 355, Try Through Huang. Ma'am, please come on the virtual stage. Is there any co-author present for this paper?
Yes,
Please start, ma'am. Over to you.
yes, I just minute now. I said screen, my screen. Can you see my presentation?
Yes, ma'am.
Good morning, everyone. My name Hương. I'm from American Banking in Vietnam. Yes, I am. Sorry. Today, our team would like to present our results on human firewall gap in the People Credit Fund system, dangerous gap between employee, information security as well as and behavior. And in the context of the digital banking, technical measures also powerful cannot replace the human factor. Employees know the regulation but do not practice them properly. Creating a security gap attacker can easily exploit. One of the current research direction is to reduce the human firewall gap. The gap between people awareness and security behavior. Our research is also in the content. The content specifically we study this issue in the BCF in Vietnam. This is decentralized network with more than 1,200 funds and nearly 2 million members. Small scale and limited IT resources. The digital transform process is uneven, leading to many security vulnerability because funds are closely linked to payment system and data sharing. Scalability in insurance in a small unit can also spread and become a system risk. Our research question are let's talk about our research question are the first measure the gap level. The second is the underneath impact on the entire PFC network, and the third possible solution and to overcome it. And our methods is quantitative methods and to answer objective and generalizability. About data, we took data from a previous survey conducted with 1,076 per PCS, accounting for nearly 97% of the entire system. So it has a very high correct and representation. About methods, we use international tools such as SAISQ and CAD model, which similarly measure closed attitude behavior in information security developed by a person in 2013. CAD model, do you know the CAD model with closed and attitude behavior? And is a fundamental information security organized research. Assumptions that would closed correcting forming a positive attitude and leading to safe behavior. In the term analysis, we combine descriptive statistics, conspire alpha reliable test, and factor analysis and structure equation model to define the factor that most strongly influence the gap between perception and behavior, the human firewall gap. And the topic survey data includes 5 topics. The first, custom data transaction security. The second, employee screen and security. The third, risk response capability. And the fourth, compliance with the SPV standards. And the last, support from external organization. After that, we mapping the topic to the SAISQ and CAP model. The topic one, mapping with the information handling. The topic 2, mapping the staff awareness, mapping general awareness, and the risk response measure, mapping incident response management and system management, and the first, compliant with the SBV standards, mapping with policy compliance, support for extension conditional mapping with related to policy enriched, and analyst. We have a result, and we analyze the results. The first, the compact alpha reached the by yes.
Please wrap it up soon. Your time limit has reached. Please wrap it up soon. I'm saying.
Okay. Okay. And we Christian awareness and staff screen score only 1.81 out of 4. Confirms that human factor remain the weakest link in the PCF digital security. The variant uh, by 0.89 range alpha so strong despite why some PCFs improve awareness and accompanying many still lack even basic clothes or screen. The gap is investing in technology. If people do not practical it properly, the system can easily collapse within. And from the statistical analysis leadership, it can be seen that the risk response lows medium and the component highest corporate risk farmer not translate into acute security need and weak human capacity. This gap is like this gap is like reverse bottleneck, and despite technology investment, if people do not practice properly, system can easily collapse from within. So we propose as a solution the human development program in the PCF system to narrow the gap between information security knowledge and behavior, helping to detect, respond to and minimize risk from human factor. The intervention framework is based on 4 billion people process technology policy government at our proposal combines on government and accountability and through the training and through the incentive and typical support and the third party management and measure of the feedback look with the CAP model and we propose the RASMAT for the training the staff in the PCF and the resource and pocket allows the success and the indicator and the sorry. Okay, and consolation of and future work. The study found that there human firewall gap in the PCFS network, where information security as awareness is not translated into actual security behavior. Cause include lack of expertise in systematic training and weak engagement with third party. To arrest this, the study possible for build a framework of people process technology policy, which measures such as role based training, phishing simulation, and implementation of the technical support tool. And the future study should evaluate the effectiveness and cost benefits of the measure using expert mentor of enforcement design and crossing country compare with modern such as credit union of cooperative bank to examine scalability and broad applicability of purple framework. Thanks for listening and yes, that's all right. Thanks for listening. Question and answer. for me.
Thank you so much, ma'am, for such a great presentation. If there are any questions. Any question from the session chairs? So if there are no questions from the audience or session chair, we shall now proceed to our next paper. Thank you so much, ma'am.
Thank you.
So the next paper, titled Generative AI and Deep Predictive Analytics, a novel framework for business scenario simulation and risk forecasting, under paper ID 387, I would like to request Lucia T. Maglong to please present her paper. Over to you, ma'am.
Good afternoon to our technical session chair and co-chair, our host, Ms. Hansika, our beautiful host for this technical session. Of course, our co-presenters today and some guests in this technical session. This research study is a fruitful effort or result of the different authors. We collaborated. These authors are Daniel Dasig, me, Dr. Emily Libonao, Dr. Isagani Valenzuela, Dr. Fernando Talion, Pijus Duta, Sushi Kumar Singh, Paulino Gatpandan, and Chad Vincent Florentino. Now, of course, our title, Generative AI and the Predictive Analytics, a novel framework for business scenario simulation and risk forecasting. Business today operate in a VUCA environment, volatile, uncertain, where traditional AI can only predict one possible future. Generative AI combined with deep predictive analytics enables simulation of multiple what-if future scenarios, giving businesses proactive risk foresight instead of just reactive forecasting. Well, we have the research gaps. Current AI models rarely combine generative AI plus predictive analytics for business risk simulation. Most are limited to single domain use, mainly finance, and lack transparency and real-world deployment frameworks for enterprise use. The objectives of this research study is to develop a general AI deep predictive analytics framework for business scenario simulation. Another one to enable multi-domain risk forecasting with deep predictive models and to evaluate its accuracy and real-world usefulness versus traditional methods. So our literature review, we have this technology evolution, the strengths and contributions, the limitations and gaps. We have the traditional machine learning, deep learning, but the strengths, it improved forecasting, accuracy, and pattern recognition. Two is still single point prediction, limited uncertainty quantification. Generative AI with GAN's VAS diffusion models enables synthetic scenarios, stress testing, and rare event simulations. Two, a gap of no closed loop integration with predictive models for enterprise decision making, and then the real world crisis insight, which highlights need for scenario-based and risk-aware forecasting. Current AI fails during high uncertainty events, like what happened during the pandemics. We have the cyber attacks and disruptions. Now, our methodology, we have this research design. This study uses a quantitative computational design with simulation experiments and statistical validation using Python, MATLAB, and Tableau. It follows an SDLC-based development process from requirements analysis to model design, prototyping, iterative testing, and deployment of the Gen AI DPA framework. So this design ensures reproducibility, scalability, and real-world applicability through modular engineering and ML lifecycle integration. Another one, our framework design, the Gen AI DPA framework, consists of layered data ingestion, generative scenario simulation, predictive forecasting, and evaluation. Generative models, the Wasserstein, the GANs diffusion models, create synthetic stress scenarios that feed into deep predictors, risk trajectories with uncertainty. The system is benchmarked against ARIMA and XGBoost using RMSE, MAA, ROC, AUC, and FID to ensure both accuracy and scenario realism. You may refer to the framework of architecture. Database and dataset and processing, three multi-domain datasets were used: financial time series, supply chain disruption records, and ESG risk disclosures. Data were cleaned through min-max normalization, KNN imputation, and IQR-based outlier filtering, followed by feature engineering, lag variables, sentiment graph features. The data here were split into training validation and stress test sets using stratified temporal sampling to avoid look-ahead bias. So please refer to the data processing workflow. The model development, the framework follows SDLC and CRISP-DM with a generative block, producing stress scenarios in a predictive block transformers, forecasting risks with calibrated uncertainty. These models are benchmarked against ARIMA, VAR, and XGBoost, ensuring both accuracy and business relevance guided by dynamic capabilities and RBV theory with FID over KID used to validate generative realism. This is the model development architecture. Okay, evaluation metrics. We use RMSE, MAE, and ROCAUC for prediction accuracy, FID, KID for scenario realism, uncertainty calibration checks for reliability, and expert delta review to map resource to business metrics like VAR and expected shortfall. The results and discussion about this, the predictive accuracy, the Gen AI DPA hybrid beat all baselines across domains, cutting financial RMSE by 29%, boosting our OCAUC to 0.89 in supply chain risk detection, and improving ESGF1 score by 31% thanks to diffusion-based augmentation. Table 1 shows the comparative performance or results. Now, the results and discussion, the scenario simulation outputs, the generative models produce realistic synthetic prices and recovery patterns closely matching real financial time series. See the figure 6 with diffusion models improving tail risk coverage. Figure 7 visualizes LSTM base risk, probability, surpasses, and synthetic ESG disclosures showing climate shock propagation. Now, our conclusion and future work. This study introduces a Gen AI, the predictive hybrid for risk forecasting that outperforms traditional models and aligns with ISO 31000 and COSO-ERM. It improves VAR, ES, and supply chain resilience and is ready for integration into digital twins and enterprise dashboards. The framework is reproducible, scalable, and strategic. Future work includes real-time digital twin deployment, multi-agent simulations, explainable ethical AI, and cross-industry longitudinal validation. So this is our framework, generative AI and deep predictive analytics, a novel framework for business scenario simulation and risk forecasting. Thank you so much.
Thank you so much, Lucian, for presenting such a well-articulated presentation. Now, if there are any questions.
You are on mute, Dr. Catherine. Please unmute yourself.
You may turn on your audio, Dr. Parikh.
Dr. Catherine, you need to unmute yourself.
It's okay, according to him. It's okay.
Okay.
Thank you so much, Miss Ansika.
So if there are no questions, we'll move further. Thank you so much, ma'am.
Thank you.
Now, with that, we conclude our today's paper presentation session at TEAS. We sincerely thank all of our presenters for their valuable contribution and our audience for their active participation. A special thanks to our session chair for guiding the discussions with clarity and depth. I would now show the session chair certificates. Please give me a minute. Is my screen visible, ma'am?
It's showing Hansika is presenting, but I can't see anything over there. Okay, yeah, now I can see. Yeah. Okay, yeah, that certificate is showing. So will you email this certificate, Hansika?
Yes, sure, ma'am.
Okay, fine.
Thank you so much, ma'am, for guiding the discussion.
Thank you. Yeah,
Now
my pleasure.
Yeah, thank you, ma'am. Now I'll present the certificate for Kanad, sir.
Okay, yeah.
I hope it's visible.
Yes.
Thank you so much, Kanad, sir, for such an insightful session and asking so much questions. Now, before we end the session, ma'am will be emailing both of these certificates to you.
Okay. Thank you. Yeah, thank you.
Now, before concluding the session, I would like to request everyone to turn on their cameras for a group photograph. I'd request all the participants to kindly switch on their cameras. We're going to take the virtual photograph, guys. Thank you so much for such a memorable session. I'll take it on the count of 3. 3, 2, please smile. 3, 2, 1. I can only see 4 people.
No, we are 5.
Okay, 5 now. Okay, I'll take another screenshot. 3, 2, 1. That's all from our side. Thank you so much, everyone. We look forward to seeing you all in the next session.
Thank you.
Thank you. Bye bye.